If you are sitting on your couch right now, your head is actually aging a tiny bit faster than your feet. It sounds like the plot of a low-budget science fiction movie, but it is actually a fundamental truth of the universe that researchers have just proven with unprecedented precision. For centuries, we treated time like a universal constant, a steady, unwavering river that flows at the exact same speed for everyone, everywhere. We built our entire civilization on the idea that a second is a second, whether you are on top of Mount Everest or at the bottom of the Mariana Trench. But Einstein suspected otherwise over 100 years ago. And now, thanks to the invention of atomic clocks so sensitive they won't lose a single second in 30 billion years, scientists have confirmed that time is not a solid floor. It is more like a trampoline. It stretches, it warps, and most importantly, it slows down or speeds up depending on exactly how much gravity is pulling on you. In a series of mind-bending experiments, physicists have shown that if you step onto a ladder, you are entering a different temporal zone than the person standing on the floor below you. Today we are breaking down the discovery that time is relative to your altitude, and how this revelation changes our entire understanding of reality. To get our heads around this, we have to talk about something called gravitational time dilation. It is one of the pillars of general relativity. Einstein's big idea was that massive objects, like the Earth, actually warp the fabric of space and time around them. Imagine placing a bowling ball on a mattress. The ball creates a dip, a curve in the fabric. According to Einstein, gravity isn't just a mysterious force pulling things together. It is the result of objects following the curves in that fabric. But here is the kicker. That warping doesn't just affect space, it affects time itself. The stronger the gravity, the more the fabric is stretched, and the slower time ticks. This means that the closer you are to the center of the Earth, where gravity is strongest, the slower your clock should run. If you are standing at sea level, you are deeper in the Earth's gravity well than someone standing on a mountain. Therefore, time is moving slower for you. For decades, this was a theoretical concept that we could only measure over massive distances. We knew that clocks on satellites in space ran faster than clocks on the ground because they were further away from Earth's mass. In fact, the GPS on your phone has to account for this difference. If the engineers didn't program the satellites to adjust for the fact that time moves faster up there, your maps would be off by several miles within a single day. But recently the game changed. A team at the National Institute of Standards and Technology, or NIST, decided to see just how small of a distance they could measure this effect over. They didn't go to outer space. They didn't even go to a mountaintop. They used two of the most precise atomic clocks ever built and simply raised one of them by about a foot, just 12 inches. And believe it or not, they were able to detect that the higher clock was indeed ticking faster than the lower one. This is the first time we have proven that time dilation isn't just something that happens in the vast reaches of the cosmos. It is happening in your kitchen. It is happening between your head and your toes. Now let's talk about these clocks, because they are the heroes of this story. These aren't the clocks with gears or even the quartz crystals in your watch. They are optical lattice clocks. They work by trapping thousands of atoms of an element like strontium in a web of laser beams. They then measure the vibration or the frequency of the electrons jumping between energy levels in those atoms. These vibrations are incredibly fast, hundreds of trillions of times per second. Because the frequency is so incredibly high and so stable, these clocks can measure time with a precision that is almost impossible to grasp. They are so accurate that they could tell the difference in time even if you only raised the clock by the thickness of a few sheets of paper. This level of precision is opening up a whole new field of science called relativistic geodesy. Usually, when we want to map the shape of the Earth or measure the height of a mountain, we use satellites or sea level as a reference. But sea level is messy. It changes with tides, winds, and climate change. But time? Time is linked directly to gravity. By placing these ultra-precise clocks at different locations, scientists can measure the exact strength of the local gravity field. This tells them exactly how much mass is beneath the clock. They can use time to see underground, detecting changes in magma chambers, shifts in tectonic plates, or the movement of groundwater. We are turning time into a measuring tape for the planet. But why does this feel so weird to us? It's because the difference is so incredibly tiny that our human senses can't perceive it. Over a 70-year lifetime, the difference between the age of your head and your feet is only about 90 billionths of a second. You aren't going to get a younger set of ankles just by standing up. But in the world of physics, 90 billionths of a second is a massive, measurable gap. It proves that the now we all think we share is an illusion. There is no single now for the universe. Everyone has their own personal time signature based on where they are and how fast they are moving. Imagine two twins. One decides to live their whole life in a cabin on top of a high mountain, and the other lives in a house on the beach. According to the laws of the universe, when they meet up again after 50 years, the mountain twin will be physically, biologically older than the beach twin. Their cells will have undergone more divisions. Their heart will have beaten more times. Their now has moved faster. This isn't a trick or an optical illusion. It is a physical reality of our biology being tied to the warping of space-time. This discovery also has huge implications for how we understand the beginning and the end of the universe. If time can be stretched and warped by something as small as a 1-foot height difference, imagine what happens near a black hole. A black hole is an object so dense that it warps space-time into an almost infinite curve. Near a black hole, gravity is so strong that time practically grinds to a halt. If you could watch someone falling into a black hole from a safe distance, you would see them slow down more and more until they seem to freeze perfectly still. To them, however, time would be moving normally. This observer-dependent reality is what makes modern physics so mind-bending. It tells us that our perspective is everything. But let's bring it back to Earth. Why should the average person care that their head is older than their feet? Well, for one, it changes how we build technology. As our world becomes more connected and our data moves faster, the need for synchronized time becomes critical. High-frequency trading on the stock market, the coordination of power grids, and the synchronization of global communication networks all depend on nanosecond precision. If we don't account for the fact that a server in a skyscraper is running on a slightly different time than a server in a basement, the whole system can start to glitch. We are entering an era where gravity-aware timing is going to be a requirement for our digital infrastructure. It also changes our understanding of the Earth itself. The Earth is not a perfect sphere. It is lumpy. It has mountains, deep trenches, and varying densities of rock in its crust. This means the gravity field is inconsistent. By using these new atomic clocks, we can create a gravity map of the Earth that is far more detailed than anything we've had before. We can see where the Earth's crust is bulging or where it is sinking. We can monitor the melting of polar ice caps not just by looking at pictures, but by measuring how the loss of that massive weight of ice changes the passage of time in the region. Time is becoming our most sensitive environmental sensor. The team at NIST, led by Jun Ye, is already pushing the limits even further. They are looking at ways to make these clocks portable. Right now, these are massive laboratory setups that fill entire rooms and require a team of physicists to operate. But if they can shrink this technology down to the size of a suitcase, you could take these time sensors anywhere. We could put them on drones to look for hidden mineral deposits or place them near volcanoes to get an early warning of an eruption. A change in the tick of the clock would signify that a mass of magma is moving up from the depths, changing the local gravity before anything even breaks the surface. This also touches on the philosophy of science. For a long time, we tried to separate the observer from the experiment. We thought there was an objective reality out there that we were just poking and prodding. But Einstein, and now these researchers, have shown that there is no separating the two. Where you stand determines how you experience the most fundamental aspect of existence, the passage of time. It is a deeply personal reality. It means that in a very literal sense, no two people on Earth have ever experienced the exact same journey through time. We are all on our own slightly different schedules. Let's think about the scale of this discovery in terms of human history. For thousands of years, we measured time by the sun and the stars. Then we used shadows on a sundial. Then we used the swing of a pendulum. Each step forward in precision allowed us to navigate the oceans, build railroads, and eventually land on the moon. But this new step, measuring time at the sub-millimeter level, is a leap into a realm we've never explored. It is the transition from measuring time to measuring space-time. We are no longer just counting seconds. We are measuring the very curvature of the universe. What does this mean for the future of space travel? If we ever want to build colonies on Mars or the Moon, we have to deal with the fact that time moves differently there. Mars has about 38% of Earth's gravity. This means a clock on Mars will tick significantly faster than a clock on Earth. If we want a galactic internet or a synchronized trade system between planets, we can't just use a single clock. We have to create a complex network of relativistic time converters. It is a level of synchronization that makes current GPS look like a child's toy. We are laying the groundwork for a multi-planetary civilization, and that groundwork is made of synchronized light and gravity. But back to the head versus feet thing. Think about what that says about the nature of our bodies. We are vertical creatures. We spend most of our time upright. This means that throughout your entire life, your brain has been living in a slightly different temporal reality than your heart or your feet. Does this have an effect on our biology that we haven't discovered yet? Probably not in a way that we would notice, but it is a fascinating thought. Our very physical form spans different layers of time. We are literally stretched across the fourth dimension. The experiments at NIST also use something called quantum entanglement to help improve their measurements. They linked the atoms in the clock together so that they behaved as a single unit. This allowed them to bypass some of the noise that usually limits the precision of these measurements. This is where the world of the very big, general relativity, meets the world of the very small, quantum mechanics. These two theories have been at odds for a century. They don't play well together. But by using quantum effects to measure relativistic time dilation, scientists are finding the points where these two worlds overlap. It might be the key to finally finding a theory of everything. Imagine a future where you have a time map of your city. You would see that the people living in the penthouse of a skyscraper are older than the people in the basement, not just because of their birthdays, but because of physics. You would see that time flows a bit differently as you drive over a bridge or walk past a massive mountain. Our world is a dizzying landscape of varying temporal speeds. We think we are all moving together in a straight line, but we are actually swirling through a complex sea of time currents. This discovery also refines our understanding of the equivalence principle, which says that the effects of gravity are indistinguishable from the effects of acceleration. If you were in a rocket ship accelerating at the same rate as Earth's gravity, time would slow down for you in exactly the same way. This means that time isn't a property of an object. It's a property of an environment. It's a measure of the energy and mass present in a location. When you move to a new spot, you aren't just changing your coordinates in space. You are changing your rate of existence. Why did it take us so long to prove this at such a small scale? It's because gravity is incredibly weak compared to the other forces of nature. To see its effect on time over just 1 foot, you need a clock that is almost perfect. The strontium clocks used in these experiments are so precise that they won't vary by more than 1 second over the entire age of the universe, about 13.8 billion years. Think about that for a second. If you had started one of these clocks at the moment of the Big Bang, it would still be accurate to the second today. That is the level of engineering required to see the stretching of time in a laboratory. The researchers also found that they could use this to measure dark matter. Dark matter is the mysterious stuff that makes up most of the mass of the universe, but we can't see it or touch it. We only know it's there because of its gravity. If a clump of dark matter were to pass through the Earth, it would create a tiny temporary change in the gravity field. These new atomic clocks are so sensitive that they could actually detect that change. They would see time stutter for a fraction of a nanosecond as the dark matter passed by. We might have just built the world's first dark matter detector. This makes me think about how we perceive the world. We see the world as solid and static. We see a house, and we assume it is just sitting there. But in reality, that house is a complex interaction of energy, mass, and time. The top of the house is moving through time at a different speed than the bottom. The atoms in the chimney are slightly older than the atoms in the foundation. Everything is in a state of flux. Nothing is truly still, because time itself is varying across every object. It is a much more dynamic and fluid universe than we ever suspected. The NIST experiment also has implications for the redshift of light. When light climbs out of a gravity well, it loses energy and its wavelength stretches out, becoming redder. This is directly related to time dilation. Because time is moving slower at the bottom of the well, the vibrations of the light appear slower to an observer at the top. This gravitational redshift is something we see in the light from distant stars, but now we can see it in a laboratory across a distance of less than a millimeter. We are bringing the physics of the stars down to the level of a tabletop experiment. What is the limit of this? Can we eventually measure time dilation across the width of a single cell, a single molecule, a single atom? Scientists believe we can. As our clocks get better and better, we will be able to see the texture of space-time at the smallest possible scales. We might find that at the quantum level, time is even more chaotic. It might bubble and foam. It might not even be a continuous line, but made of tiny atoms of time. These experiments are the first steps into that strange, microscopic wilderness. Think about the impact this has on our sense of self. We like to think of ourself as a singular, unified thing, but your brain is at the top of your body, and your feet are at the bottom. This means your brain and your feet are literally living in different time zones. Your thoughts are happening in a slightly faster reality than the movements of your toes. There is a temporal gap within your own body. You are not a single now. You are a spectrum of nows. This discovery also highlights the sheer brilliance of the human mind. Einstein figured this out using nothing but a pencil, a piece of paper, and pure logic. He didn't have atomic clocks. He didn't have lasers. He just thought about the nature of light and gravity and realized that time had to be relative. It took us a century to build the technology to prove he was right at the scale of a single foot. It shows that our ability to imagine the universe is often far ahead of our ability to measure it. But now that we can measure it, what's next? We are going to start seeing optical clock networks across the globe. These will be used to synchronize everything from satellite launches to the measurement of sea level rise. We will have time-based navigation that doesn't rely on satellites at all. By just measuring the local tick of your clock, you could tell exactly where you are on the planet, because no two places have the exact same gravity signature. It is a revolutionary way of thinking about location. The experiments also showed that even the smallest movements can change time. If you walk across the room, you are moving relative to the Earth. This adds another layer of time dilation called kinematic time dilation. The faster you move, the slower time ticks for you. So not only is your head older than your feet because it is higher up, but if you are walking, you are aging slightly differently than if you were sitting down. There are two competing effects, gravity and speed, fighting for control over your personal clock. It is a complex mathematical dance that determines your exact age. Imagine a world where your watch doesn't just tell you the time, but tells you your temporal velocity. It tells you how fast you are moving through the fourth dimension compared to everyone else. Slow down, it might say. You're getting too far ahead of the basement people. It sounds silly, but as our precision grows, these differences will become part of our daily lives. We will have to learn to navigate a world where time is a variable, not a constant. The researchers also hope to use these clocks to test the limits of general relativity. Is Einstein's theory perfect? Or does it start to break down at very small scales? If they find a slight deviation, if time dilation doesn't work exactly the way the math says it should, it would be a massive discovery. It would point the way toward new physics beyond Einstein. It would be the spark for the next scientific revolution. They are looking for the tiniest cracks in our current understanding of the universe. As we wrap up our look at this mind-bending discovery, let's take a moment to appreciate the world we live in. We are on a spinning ball of rock, hurtling through space, wrapped in a blanket of air, and constantly warping the very fabric of existence. Every step you take, every ladder you climb, and every breath you take is part of this relativistic journey. You are a time traveler, moving through a landscape that is stretching and bending around you every second. The proof that time moves differently depending on where you stand is more than just a cool science fact. It is a fundamental shift in our perspective. It tells us that the universe is not a rigid box. It is a flexible, responsive, and deeply strange place. We are not just passengers on a steady stream. We are participants in a dynamic flow. The now is yours and yours alone. So, the next time you feel like the day is dragging on or that time is flying by, remember that you might be right, at least from a certain point of view. Your head is racing into the future while your feet are lingering in the past. It's a tiny gap, a nanosecond of difference, but it's real. And in that gap lies the entire mystery of the universe. We are living in a world where time is a mountain and a valley, a river and an ocean. We are finally learning how to read the map. Stay curious, stay inspired, and never stop questioning the world around you. Even the most obvious things, like the time on your watch, can hold the most incredible secrets. The discovery that time is relative to your altitude is just the beginning. As we continue to build better clocks and better theories, who knows what else we will find? The second is no longer just a second. It's a window into the warped and wonderful heart of space-time. Think about the researchers sitting in that lab in Colorado, watching the two clocks. They weren't just looking at numbers on a screen. They were seeing the curvature of the Earth manifest in the frequency of light. They were watching the gears of the universe at work. It is a profound and beautiful thought. We are the first generation of humans to see the texture of time in our own backyard. And so we leave the lab and step back into our daily lives. But we do it with a new understanding. We are vertical travelers. We are gravity warpers. We are time experimenters. The simple act of standing up is an act of relativistic physics. The universe is not somewhere out there. It is right here, in the 1-foot gap between a tabletop and the floor. It is in the now that belongs only to you. Thank you for exploring this hidden layer of reality with us. The world is a lot more interesting when you realize that even time isn't what it seems. We've moved from the stars to the tabletop, and the mystery only gets deeper. Keep your eyes on the clocks and your mind on the stars, because the journey through space-time is the most incredible ride of all. The proof is in the tick, and the tick is telling us that everything is relative. Welcome to the new age of time. Welcome to the flexible universe. Welcome to the reality where every inch matters. This revolution in timing is just getting started. As these atomic clocks become the new global standard, our world will change in ways we can barely imagine. Our navigation will be perfect. Our geological knowledge will be absolute, and our understanding of the cosmos will be deeper than ever before. We are no longer just living in time. We are learning to master it. And it all started by simply raising a clock by 1 foot. That is the power of science, taking a small step and finding a whole new world. So go ahead and stand up. Stretch your arms. Feel the gravity. You are entering a new temporal zone. You are an explorer of the 4th dimension, and the map is being drawn as we speak. The universe is wider, deeper, and more flexible than we ever imagined, and time is the thread that ties it all together. Let's keep pulling on that thread and see where it leads us. The next second is waiting, and it's moving at exactly the speed you decide. Stay curious, stay amazed, and always remember to check your altitude. The time of your life is literally up to you.